Awesome. So one of our other teams, actually, their team leader, Rob, wanted to say something real quick. I think he didn't really.
I just wanted to say really quick. So our project, it didn't end up being completed, but I did want to definitely want to give a shout out to Michelle Berta, who's on the call. She did a really wonderful job. And it's like our team, we had a lot of planning up front and things kind of fell apart. But I just want to give a shout out to her because she did a ton of stuff with like our login page and our registration page. She started to build some of the core features we were going to have. And she did all that with React, TypeScript, with Materialize. And it was coming together really nicely before things started to fall apart with the team. So just want to give a shout out and make sure that that was recognized at this time because that was a lot of work. So yeah, that's it.
I guess back over to Jonathan, unless he doesn't have anything.
I thought you want to say something about the cohorts coming up.
Yes. Let's see. I posted up at the very top before things got really hefty, and then Jonathan posted again. The new website has a link on there, and what we're going to do is we're going to wait a couple of weeks. Let me grab this again. Oh my goodness, scrolling on here with the trackpad. Okay. So there's the new website. We're going to wait a couple of weeks, the rest of this week, at least the rest of next week. And then we are going to, we're kind of working on updating our, I guess, our process on how we're going to sign up for the cohorts. It's going to sign up pretty similarly, and we've not completely hashed this out yet. But in order to try to hopefully prevent some of this stuff, or rather, I guess, encourage, I don't know the right way to say this, but like to hopefully give a better chance of success for those who do sign up, we're going to be working on slightly tweaking how that process goes, and we're probably going to extend it to like a 2-week process where there's like some communication, more communication involved than just like, hey, sign up and then we'll send you a single email and then y'all get started kind of thing. So we'll be talking about that here in the next couple of weeks on the Discord and letting y'all know as things are decided, or once a plan is definitely decided by the administrative team. And we'll probably start the signups probably like during the first week of April kind of thing. And we'll let y'all know.
Cool. Thanks, Scott. Yeah, definitely consider being in one of these cohorts if you can. It's not fun when it fizzles, I know, but we are taking steps to make sure that doesn't happen as much. And there's a lot of potential there. Like, I mean, you know, and I feel pretty good about the project we built, and that wouldn't have happened if we wouldn't have signed up. So anyway, cool. That's enough about that. I think we took up enough time. We knew that nobody else was presenting, so we were like, let's just share the thing. But anyway, cool. So I have the privilege of introducing our speaker for the night, a ninja of the back end, Steven Torrence.
Hey everyone. Thanks for that intro, Jonathan. And man, SEAL Team 3, just so impressed with the project that you guys, you know, the product you guys were able to create just from the, you know, from the top down, like not only the final product, like digital product, but like the process too, seeing the Kanbans in GitHub and then seeing the designs in Figma. That's really cool. And I mean, Jonathan knows this, but I mean, that's how it's done. That's the real process. So, you know, for you guys to kind of get a taste of that maybe, you're in the process of looking for a job. That's going to be so valuable. Okay, cool. So let's talk a little bit about the back end. Let's see if I can do this. So I've got like a ultra wide screen. So sharing my screen is always a little bit of a chore here. Let me know if you guys can't see that. And then I'm also all about the vibe. So I'm gonna bring the music back, and hopefully it doesn't sound too distracting. But there it goes. Cool. Also at the top, you'll notice there's a link, which I'll throw here in the chat. So as I'm going through this, I've never used Google Slides before. Back when I was teaching, I don't think Google Slides was as popular as it is now. So I was kind of blown away with all the features that it has. It's got this kind of like audience tool that allows people to click on that link and submit questions in real time. So if you have a question, you can either drop it in the Zoom chat or you can drop it in the Google Q&A, and I'll do my best to try to answer them. I like it because it's a good way of, some people may not like, coming off mute and maybe interrupting or whatever, feel like they're interrupting, which, by the way, the absolute last thing I want is for this to feel like it's a lecture, like you're in college, listening to a professor lecture or anything like that. Sort of my vibe, my style is open conversation. So if at any point you have a question or something doesn't make sense, or you just want to know more about something, feel free to drop a line in the QA or in the chat, or just come off mute, and we'll take that as sort of like a learning opportunity to sort of go down that tangent. So I love tangents. But this is my intro to the back end, and this is by no means a comprehensive, I'm not going to cover every single thing involved in the back end, but I'm going to try my best to sort of hit the popular topics. I'm going to go ahead and move the Zoom chat just a little closer so that way I can see any messages that come in. All right. Oh yeah, I have this cool little like laser pointer too. That comes with Google Slides. So if you ever need to do a presentation, Google Slides is where it's at. How do I get my voice to come out nice like that? I mean, it's just, it's one of those things that you're just born with, No, it's the mic. All right.
This is definitely a podcast voice. Like,
dude, you're not the first person to tell me that. Maybe I should look into that. Maybe there's something there. Dude, what if we started a free code camp podcast? We'll talk about that. All right. So what is the back end? How is it different from the front end? All these questions that may be running through your mind. Well, I'm going to start with a real quick disclaimer. In my personal opinion, terms like front end, back end, full stack, those should all kind of be taken with a grain of salt. They're important to know for, like employers love to use those terms. People that write job descriptions love to use those terms. But from my experience, if you're a back-end developer, you're going to be at some point working on the front end. If you're a front-end developer, you're going to be working on the back end. It's just kind of how development goes, especially with the way technology is recently. Modern frameworks, modern libraries, I feel like the lines that divide front end and back end are slowly becoming more and more blurred, which is a good thing in my opinion. It helps you become more of a well-rounded, developer. So that's just my disclaimer. But with that said, so here are a couple examples of what I mean by when I say the lines can become a little bit blurred. Front end extending into the back end. Those of you that have done any work with any front end framework, about client side routing. This isn't something that used to exist before front end frameworks. Most of your routing would be handled on the server, but now because of the more complex UIs, responsive UIs, we have need for client side routing. If you've ever worked with Next.js, you're familiar with server-side routing and static site generation, two very helpful tools that come with Next.js. And some of my favorite tools, loaders and use loader data. If you've ever had a chance to check out Remix, I know Rob is a big proponent of Remix. It's really cool, kind of the new kid on the block. I really like how Remix uses loaders and use loader data to kind of blur the line between making queries inside of your component file. So that's an example of the front end extending into the back end. On the other side of things, you've got the back end extending into the front end. So if you're not as familiar with these tools, this is kind of what's been taking the back end world by storm. In the Rails community, there's something called Hotwire, which is a clever little name for HTML over the wire. If you're familiar with Phoenix Live View, Phoenix is a framework for Elixir. And then there's also Stimulus Reflex, which kind of uses similar technology and WebSockets. But basically, the goal of these technologies is to make the front end more reactive. The goal of these technologies is by no means to replace React or Angular or JavaScript on the front end. Nothing like that. In fact, I don't think they could if they wanted to. But these tools allow backend developers the opportunity to make their apps more responsive, to build a little bit more complex UI. So that's an example of the backend extending into the front end. So with all that said, I don't think there's any reason to scrap the terms front end and back end. They still are good at describing, handling different parts of the app, especially, during product development. Okay, with all that said, how do we define what is the back end? I think a great place to start is by taking a look at this. This is the HTTP request and response cycle. This is kind of like ground zero. This is where you start. If you want to have a career in web development, you got to know how this request response cycle works because it's so important. This is the foundation of everything we do. So the user makes a request in the browser, that HTTP request gets sent to the server, and some stuff happens on the server. Either stuff data gets queried for and gets sent back to the client side, or mutations happen. So either a resource is updated or created or destroyed, and that resource information, that resource data gets sent back this way over to the client side. That's basically, it's not complex. That's basically the entire cycle simplified. So today we're going to be talking about everything on the right side of this cycle, known as the back end. So here's kind of how I would, in general, break up the back end into different components. You've got your web server and application server. You've got your databases and your ORMs. If you're not working with a front-end framework and you're working with something with Rails, Ruby on Rails, Django, you can have server rendered views. So we'll talk a little bit about templating engines. Super big component of the backends is our APIs and GraphQL. And then we'll talk a little bit about cloud development, DevOps, CI/CD, and containerization. Those oftentimes, or sometimes, will get kind of thrown in with the backend. Those really are, those are separate fields of development. And you can be, even with databases, you can be a database administrator, and your gig is just databases. Or you could be a straight up just like cloud developer, and that's your gig. Those fields run deep, but oftentimes they get kind of thrown in with the backend in general. And then here you can see a couple of icons that I picked out just to kind of represent the backend. Got Postgres, Travis CI, if you're familiar with that, if you're familiar with building pipelines, GraphQL, and we've got our cloud providers here. AWS, Azure. I'm never quite sure how to say that. And then GCP, Google Cloud Platform. Cool. So let's talk about the first thing, web servers versus application server. And this is something that I kind of struggled with early on in my career. Like, you know, I just thought they were both the same thing. Turns out the web server's main job is to display content, while the application's job is in charge of the logic. And we're going to talk a little bit more about that and go into depth about the differences there. This includes interactions between the user and the displayed content. So that's what a web server does. The application server works in conjunction with the web server, so that it's not like one or the other. It's not like you can have just a web server and not an application server, or vice versa. They work in conjunction with each other, and we'll go into examples of that. Two popular web servers, Apache and Nginx. There are others, but those are the ones that I've worked with. Those are the ones that I hear about all the time. They're both written in C, which is a programming language. If you're not familiar with C, it's super, super fast language. It's been around for a while, I believe. I think maybe early 70s, maybe even before that. Key signature. Yeah, it's also a key signature. It's a note in music. Yep. But it's great language for writing web servers. You guys are hilarious in the comments. You know, Rob, I could go for that as well. So web servers, application servers. Application servers can be programmed in many languages. You've got your Node, Ruby, Python, PHP, Java, Elixir, all the good stuff. C#, Golang, Rust, Crystal. The list goes on, and I've got a couple of the logos there. Now, popular frameworks for these application servers are Express.js, Koa, Nest. In the project earlier that Jonathan was presenting, he showed a little bit of the backend code that was written in Nest. So that's a backend framework in JavaScript or TypeScript. You've got Ruby on Rails, you got Django and Flask, which is a micro framework, Laravel, Spring Boot, Phoenix. So let's talk a little bit about application servers and web servers. If you're familiar with Node, that's kind of like the example that I kind of go to in my head. So when you're building a Node application, just vanilla Node, no frameworks or anything, you can create an application server just in a single file. Think about your server.js. And all it does is it's gonna load up the server, and it's gonna listen on a certain port. That's an application server, and then that's gonna work in conjunction either with Nginx or Apache to deliver content to the user. Remember that HTTP request response cycle. However, as your application grows and becomes more complex, you'll need to handle more of that logic. That's where frameworks come in. Frameworks provide a framework for handling that logic. You can create controllers. If you're familiar with the MVC way of building things, model, view, controllers, you have models, which your resources are represented in those models. You have controllers that handle the routing inside of your framework application, and then you have views for displaying those. So let's move on. Databases and ORMs. So popular databases are the ones you see there below. The databases that I'm most familiar working with are relational databases. So, ones like MySQL, PostgreSQL, SQLite, you may have heard of those. Those are all relational databases. Now, what that means is they use a primary key and a foreign key. And the easiest way to think of a relational database is to think of them as tables with associations. So kind of like spreadsheets. If you've ever, done extensive work in an Excel or a Google Sheet document, that's basically a database. That's a simplified database. made up of rows and columns. On the other side of things, you have your non-relational databases. These databases are not like Excel spreadsheets. They're more like document stores or key value stores, or they could be graph-based. Jonathan mentioned this when he was talking about his project, his team's project. The database that they ended up going with was MongoDB, so a non-relational database. Typically, databases are hosted on their own server. So if you're familiar with setting up an application from scratch, either in AWS or in Google Cloud, typically you would have to set up your database instance and have it connect to your server. So already we've got two parts of the backend. We've talked about web servers and application servers, and now we're talking about databases. So those are the two primary parts of the backend. That's where all our data is stored. So how do we talk to these databases? Well, primarily we'll use, if it's a relational database, we'll use SQL to talk to it. We'll write what's called SQL queries. However, there is something called an ORM, which stands for Object Relational Mapping. Basically, it's a fancy term for software that abstracts the SQL code and lets you write more human-friendly queries. And basically, it'll translate that and send that as SQL to the database. So you can see here in this diagram, we have objects, and you can think of these as sort of like your resources. Basically, they're being modeled. So like if you had a user's resource, so all of your users, or to use the example from earlier, if you had a budget or an expense, or rather, that could be mapped as an object. And you'll use an ORM to query for that in the database. So it lets you manipulate data from a database using an object-oriented paradigm. Basically lets you work with models and abstracts away the SQL. Popular ORM libraries include Active Record, SQLize, Prisma is an ORM. I think a lot of people, and maybe this is just me, because I originally thought Prisma was just a database, but it's actually not. It's an ORM because you model, you create a schema with Prisma that models your resources, which is great. And you've got Type ORM and Mongoose, which I believe is often used with MongoDB. So that's basically ORMs in a nutshell. Let me check the Q&A real quick, make sure I'm not blowing through any questions. Yeah, Rob, I love Prisma. It's really cool. Some of my coworkers showed that to me recently. And it actually reminds me a lot of sort of how Active Record handles things in the Rails world. Because you've got Active Record lets you do migrations, and I found out Prisma lets you do the exact same thing, which is really cool in setting up the schema. So definitely interested in learning more about Prisma as well. So if you're not working with a front-end framework like React or Angular or Vue, you'll have server-rendered views, which use a templating engine. And all that means is it's basically going to evaluate some code, which is like either going to be JavaScript or Ruby, before sending that template over to the front end as HTML. The templating engine replaces variables in a template file with actual values. And then it sends that over as HTML to the client. So that's all that is. But with the popularity of React and Vue and all those front-end frameworks, server rendered views are becoming less and less popular in place of those UI libraries. So, all right. So we've got our web server application servers that we've talked about. We've got our databases and our ORMs. We talked about the views. Here's the next big chunk of what makes up the backend: APIs, and what we're going to talk about GraphQL specifically. So if you're not familiar with APIs, it's just a fancy term that stands for Application Programming and Interface. And all that means is a set of defined rules that allows software or apps to talk to each other. So if you've ever, built a weather app, or what another popular one is the Pokemon app, you've interacted with APIs that do that for you. Because you think about it, another way to think about APIs is, if you wanted to do the weather, pull weather into your application, weather data, you could do one of two things. You could either hook into an API for the weather, so, local weather API, or, you could build your own satellite, launch it into space, maintain it, and, handle all that data on your own. So APIs prevent us from having to do things like that. The example I like to always think of is going to the store to buy stuff for a sandwich, like bread, deli meat, mayonnaise, if you're into mayonnaise, things like that, versus actually growing the wheat in your backyard, harvesting the wheat, baking the wheat, doing all that stuff, like, growing chicken, is that deli meat? Yeah, like, I guess ham or chicken, whatever you get, turkey, growing those animals so that you could, make a sandwich. That's I think I've gone down a tangent with this analogy, but APIs would be like the grocery store. So that way you can get your resources from there. GraphQL is a fairly recent paradigm that's shown up. Stands for Graph Query Language, and it's basically a language for APIs that allow devs to have more control over what they're querying for. And we're gonna look a little bit into that and see what that looks like. So if you're familiar with working with APIs, you might have come across something called RESTful APIs. And if an API is RESTful, it just means, REST, by the way, stands for Representational State Transfer. Well, who named these things, man? I wouldn't name that. That's too long. REST is basically a fancy term for defining a set of rules for how the architecture of your API is to function. Those rules are based around HTTP methods and resources. So we talked about resources earlier with ORMs. REST APIs typically follow the pattern of get, post, put, patch, and delete. So if you're familiar with the term CRUD, C-R-U-D, stands for create, read, update, destroy. Each of these HTTP methods maps to one of those actions. So for C, create, that could be a post request. Read would be a get request. You're reading in data from the database. That's a get request. Update could be a put or patch. And then delete for removing the data. I love CRUD. Yeah. Every time I talk about CRUD in front of our designers at work, they're like, really? Is that a technical term? I'm like, hey man, like, that exists. Like, we're talking about CRUD here. We're talking about APIs. I think they think we made up that word, and like, no, we didn't make that up. That exists. That's a thing. I wanted to put a little thing about URL encoded parameters, but I was running out of time, and then to make this, to finish these slides, and then two, it's not necessarily just backend related URL encoded parameters, but because you will deal with them a lot on the front end. I just always think that they're neat. You can do a lot of cool stuff with that. So take a look at that if you ever have a chance. But that's basically RESTful APIs in a nutshell. You're going to follow these HTTP methods. Yeah, it does feel like percussionists make up words. Like, you can't tell me some of those rudiments aren't made up words. Like Flamacue or whatever. Like, I don't, come on, who made that up? All right, GraphQL, Graph Query Language. So it was created by Facebook and was released to the public in 2015. I think the story goes that Facebook created GraphQL and used it internally for a little bit before releasing it to the public. But basically, GraphQL is a server-side runtime, and it executes queries and mutations. And here's the great thing about GraphQL. it allows you to use a type system to help define your data. So, if you're familiar with TypeScript, typing can save you a lot of pain and heartache later on down the road. So that's one of the reasons why I'm a huge proponent of GraphQL. One key point is that instead of the server dictating what the response will look like, which is typically what you get with a REST API, you query for a user, the server is going to send you back the entire user, first name, last name, email, date of birth, all that stuff. You don't get to dictate what that response will look like. The server does. The difference with GraphQL is the shape of the response is dictated by the query itself. So we'll take a look at what that looks like here. So here's an example of a GraphQL query. So this really gives front-end developers or whoever's making the request flexibility on the front end, because here I can query for, they have a hero resource. So, okay, we'll go with that. Hero. I can query for a hero. I can grab the hero's name, but then I can also grab the hero's friends. Now, this is huge because I'm able to do this in one request. Whereas before, with a REST API, I would first have to query for the hero. That's one request. Once I have the hero back in a response, then I can query for the hero's friends. That's a second request. So already I've cut my number of requests in half, which is huge. And then once I have the friends, I can query for the name, their homeworld, the homeworld's name, homeworld's climate. So like GraphQL is an incredible tool for giving you flexibility on the front end to query for the exact data that you need. And then here on the right side, you can see the type system. So a hero is a character type. Well, what is a character type? Well, here's a character type right here. It's made up of a name, which is a string. They have friends, which are just arrays of other characters. So love that about GraphQL. All right, cloud development. Now, so we've talked about web servers and application servers. We've talked about databases and ORMs and how databases are typically hosted on their own server. We've talked about APIs, or we talked about views, and then we talked about APIs and GraphQL, which is how software talks to each other, right? So like think front end, how does my front end talk to my back end through an API? Now we're talking about cloud development. And, like I said, this kind of gets grouped in with backend, but really you could have a career just as a cloud developer and make pretty good money. So with cloud development, there are a couple of terms that come along with that. If you're familiar with infrastructure as a service, basically services like AWS, GCP, DigitalOcean, those are all infrastructure as a service. They're cloud-based services that you pay for as you go based on your usage, based on your storage, what type of networking and virtualization you have, you're needed. Platform as a service, hardware and software tools available over the internet. So like AWS Elastic Beanstalk, which lets you kind of spin up an app right away. Heroku's the same way. Salesforce, which I think Salesforce owns Heroku now, so that may be the same. Software as a service. This is, as end users, we're most familiar with software as a service because think about apps like Google Docs, Google Sheets, Dropbox, Zendesk, HubSpot, Slack. Those are all services that are in the cloud. Backend as a service. This one's interesting. Cloud computing strategy that serves as a backend for apps, typically mobile apps. What I think of whenever I think of this is I think of like Firebase. Firebase is a good example of backend as a service. Instead of rolling out your own backend solution, you can essentially sign up for Firebase. And what that gets you is, I believe it gets you a database, or you may have to add that. I'm not entirely sure. But you can also add authentication, like as a package, as like an add-on, and boom, you have authentication instead of having to build it from scratch and handling tokens and all this and that. Like Firebase has that built in, or you can add it on at least. AWS Amplify, things like that. Backend as a service is typically aimed at developers, whereas software as a service, we were talking about that earlier, that's primarily aimed at front end or end users. Jonathan, handling tokens, Chuck E. Cheese. All right, so that's cloud development. And I saw this really cool picture online that I thought does a great job of kind of helping visualize what cloud development, each of those services we talked about, infrastructure, platform as a service, software as a service. So this is what they used to do, and some businesses still do to this day, which is on-premise, which means your servers are located on site. You are in charge of your own servers. That's huge. It takes a lot of time, effort, money to maintain those things. And these are all the things that you would be in charge of. Your own networking, your own storage, your own operating system, your own virtualization. If you use a service like AWS or GCP, the infrastructure as a service, you're in charge of just building the app. You're in charge of handling your data, the runtime, the system stuff like the middleware, but you're not in charge of the servers. You're not in charge of the storage. People handle the physical hardware of all that. The network, you don't have to hook those things up, like physically take the wires and hook those things up. People do that for you. Others will manage that. Platform as a service, even less responsibility for you. You're just in charge of the app and the data that the app holds. They handle everything else, which makes sense, right? Think about like Google Docs or Google Sheets. Like we as end users just work directly with the app and the data, but we don't do anything with the servers or networking. And then software as a service. There you go. So some great questions here. What case is it better to use GraphQL instead of a REST API? Does a rule exist? Not necessarily. It's going to depend, right? Just because GraphQL lets you format the response however you need it doesn't necessarily make it better than REST. There's still a couple of things that REST, they're like tools, right? You choose the best tool for the job. There are a couple of things that you can do with REST that necessarily you can't do with GraphQL. Versioning comes to mind. And maybe it's because I'm more familiar with it, but I feel like it's easier to update your API version with a REST API than it is with GraphQL. And we'll talk a little bit about that here because I know somebody had a question about that. I think this may be the last slide, DevOps. And DevOps is its own world, has to do with, it's a whole paradigm, a set of practices that combine software development, which is the dev part, and IT, which is the ops part. Basically, it aims to shorten the development lifecycle and provide continuous delivery with high software quality. You can tell I didn't write that. That was a copy paste job, I think, from some website talking about DevOps. But what does that mean? Well, you've got these different parts. I'm not going to go through all these. You can kind of read them on your own. But coding, building, testing, packaging, releasing, configuring, and monitoring, those are all part of DevOps. And I listed these tools down here at the bottom because to kind of tie back to what we were talking about earlier in the talk, how the lines are kind of blurred between front end and back end. I feel like these tools, Netlify, Vercel, if you've ever worked with Next.js, they have a tool called Web Vitals. Those are all what could be considered part of the DevOps stack, but they're tools that help you deploy your front end application. So just another example of how the lines get blurred between what's considered front end and what's considered back end. And then you have CI/CD. So if you're familiar with setting up pipelines, basically all a CI/CD is it just any change that a developer makes to an application gets automatically bug tested, unit tested, system tested, and then uploaded to a repository like GitHub or wherever you have, if you have an EC2 container or something like that, where they can be deployed to a live production environment by the ops team. That's all that is. Last thing, containerization. This is a topic I'm not too familiar with myself. I haven't had a lot of opportunities to work with containers. If you've heard the term Docker, Kubernetes, this is something that I'm interested in learning in, but basically you containerize your app for reasons, these 3 reasons: ease of deployment, scalability and flexibility. You can easily scale up your apps during peak hours, or you could scale it down, when people aren't accessing your app. And then consistency. As a developer, one reason why I would want to look at containers is for getting people up and started working on development. Like, one of the hardest things as a developer is setting up your environment, downloading the right packages, making sure you have the right Node version or the right Ruby version or the right Python version. You don't have to worry about any of that stuff with containers, because you have an image file that it's like a recipe. Here are the steps to create this fantastic dish. You just put it, give it to the machine, and it creates your app for you. You don't have to worry about, what if I don't have 2/3 cup of water and I mess it up or something. So that's containers kind of in a nutshell. And that is the last slide of my presentation. So hopefully I didn't go too long there. If you guys have any questions, feel free to hit me up either on in the Discord server, or you can add there's my Twitter account. Trying to be more active in the Twitter dev world. There's a whole world out there, and it's a great way to, if you follow a lot of developers, Dan Abramoff, some of the other guys that are creating these wonderful tools for us. Twitter's a great way to ask questions, get in touch directly with those guys and gals. So yeah, hit me up if you have any questions, and I'll be around. Thanks.
That's great, Steven. Thank you. Anybody got any questions? I think you would have faded the music, and then I just interrupted. So, which is, par for the course, honestly. That's what I do.
Oh, the music was still playing for me on my end. So it sounded like the music was still playing.
We could just imagine it.
Yeah.
Cool. All right. Well, if we don't have any questions, oh, there we go. You can leave the music. I mean, honestly, I'm gonna post all these links again. So, honestly, Discord link and Free Code Camp hangout / lunch at Steam Theory tomorrow at noon. I would love to see some more faces and meet more developers. So, anyway. The address and everything is in there too. So cool. Well, we can just ask questions or talk and chat, whatever y'all want. So you gotta go, you can head out,
I have a question for you, Steven. When it comes to one of the big pitfalls for people that I've noticed when they're coming to learn writing Rust APIs is that Rust has all these conventions that we don't generally talk about. So the put, post, patch, get, delete options and all that stuff is kind of like the first step. But I mean, if you're looking at a Rust API that was designed by someone who knew what they were doing versus someone that was kind of new, at first glance, I'm sure there's things that are just give it away, right? I was wondering what some of those are that you've noticed, and what are the important things for us to pay attention to, right?
Yeah, that's a great question, and it sounds like a question from someone who has had to work with some not great APIs. And I can tell you, man, I've been there myself, and it really does feel like, I mean, there are these conventions, but at the same time, people will often architect their APIs in a way that it feels like the conventions are more sort of just suggestions. And it surprisingly, you see it at some kind of like mid-level / even large companies, large businesses that have integrations that people will often bring into their apps, which is kind of surprising. But my solution, or I guess my suggestion for that is, and this is going to sound kind of like obvious / like not really an answer, but is to look at the documentation. Like, I feel like if it's well documented, they kind of, even if they don't stick necessarily with the paradigms of, you know, this is a REST API, we're going to do these things. If they have good documentation and they kind of explain their reasoning for why they set things up a certain way, that, you know, that can kind of help kind of ease the pain just a little bit. But yeah, you're definitely right. And just like with anything, I feel like software related, just because there's a paradigm or a convention, certain way of doing things, people will often find ways to do things differently. And that's not necessarily a bad thing. I feel like that's how innovation happens, you know, just kind of organically. It's also how you get a lot of things wrong too. But I feel like that's such a great question that I necessarily don't have the answer for. But that's sort of where I would start, is with the documentation.
Well, thanks, man.
I've got a question for anyone who feels like answering it. How's everyone's journey going? Whether you're looking for a job, or you're just here looking to talk to people, or maybe you have a job and you're looking to level up. How's your journey going? How can we help you?
I can go. I think for me personally, like I already mentioned, like this